Hello and welcome back to another episode of Advanced RC Adventures. A2RC here. This is a channel where we investigate, explore, build and explain, upgrade, and advance Nitro RCs to another level. Come start a new adventure with me. Today we do have an adventure for you, another Nitro engine overview. We have the Force-made HPI G3.0 18 size engine. This is a brand new engine. Have it here sealed in the bag. This has already been inspected, lubed, cleaned, sealed back up, put into long-term storage and ready for a future build. But here today, ready to explore the insides and outs, have a little conversation about it, and have some fun doing it. So let's get it out of that bag and start the adventure. So let's do a little walkthrough here. We have our HPI branded, has power down below, an SG shaft engine, pull start. All of these ready to run style Force engines made for HPI are a pull start type of variant. The backplate and the style of pull start are sometimes a little bit different, but at least currently all of the RTR style engines made by Force for HPI, we have our desiccant bag here that just fell out, are with a pull start. We have Nitro Star, which is the very, very long running vintage now name or branding for HPI, is present on the backplate at Nitro Star. HPI Racing engines. We have the 3.0 little logo or label here on the side exhaust portion of the engine. Notice these use the engine mount flange or auxiliary flange, sometimes called no integrated engine mounts here. We have a carburetor. It's a rotary style. We'll take a look at that. And like all of our engine overviews, we'll take that carb off. We'll pop off that back plate, take a look at the internals, take out the head, and explore along the way. So these pinch bolts, these use a standard 6mm pinch bolt. Take out the carb here. There's no O-ring down inside. This carburetor is almost a fully composite style carb. On the casting here it says HPI. This is a 2-needle carb. We have our high-speed needle here. It's got a nice brass inlet nipple there. The low-speed needle here is on the mixing cone side of the carburetor. This uses two different O-rings. We have one down there on the neck and we have one up there. So that's a little bit nice to have two different seals. Rotary style carb. Let's go ahead and measure that bore down inside. So this is a 6.5mm bore. Definitely not a roar legal kind of carb size, but it's not a race engine either. Standard butyl kind of dust cover or boot. Our idle gap adjustment or needle there in front of the carb. So just a standard kind of carb, but it is relatively big bore for this 18 size engine. Let's go ahead and take off this back plate. It's like we use a 2mm hex for these bolts on the back. It only uses 3 bolts. Always be careful when taking off your pull start so that the spring does not pop out. You can use a hex wrench or a flat screwdriver or a credit card or something. Put it in between. Make sure that you're pulling towards that pull start and you're trying to make sure that when you take this off the shaft or the one-way bearing, that the spring-loaded insert does not pop off. Now these style have a retainer, and so it's not really able to pop out, which is great, but it's always a good practice to try to do something to make sure that that retainer, the spring, does not pop out of there. So this style has the one-way bearing on the outside of the back plate. Definitely some style engines have the one-way bearing inside. I definitely prefer engines like this that have the one-way bearing on the outside and then the starter shaft going in. It's always curious, this starter shaft is a 6mm starter shaft. There are some engines, especially some vintage engines, that have a different diameter shaft. We'll go ahead and take out these back plate bolts and keep on keeping on. Now, Force is one of the few manufacturers right now that is creating small block engines, especially the ready-to-run style engines. And a sister engine to this G3.0 is the T3.0. We're going to take a look at that on a next engine overview. And the back plate that it uses and the pull start is a little bit different. So, but we will go ahead and take a look and discover the differences between these Force engines that are all in that sister family. So the starter shaft pops out. Pretty long starter shaft there itself. This style, all these style Force engines use a little ramp inside and then hold. We'll show you the pin, and there's a spring inside that when it rotates, it holds on to that pin and it'll help to start and rotate that piston. Fuel and air mixture will ignite it and continue to spin. It acts kind of as a one-way system, so if it rotates the other way, it will simply rotate and pop in and keep on going. But once it goes this way, it goes down inside of this groove and catches on, and then it'll rotate the crankshaft and piston. Take a little look at this back plate. This design is a little unique. It's a semi-interference engine. We have our flat here. It uses a butyl O-ring seal, which is great. No paper or plastic gasket on the back side of the back plate, so you should have a nice seal when you take apart the engine and the back plate. You have another flat here on this side of the back plate. This very well may be utilized for different style engines, and they try to have one part number back plate for multiple engines, and it can be rotated to a different position. That's my speculation. I haven't dove into that, but just taking a look at the design, that's what makes me think about that. That's what comes to mind. Let's go ahead and take out this pin. See, there's a small pin, and there's a spring behind there that goes inside the crankshaft. We'll take a look. And that falls down inside of that starter shaft little cam portion and catches on. And when you pull on the pull start, it spins that crankshaft. So we definitely don't want to lose those pins. Down inside of that crank bore down there, there's a little spring. Now, you don't necessarily have to take this spring out, but I would recommend it, and I always try to. That way, when you're moving around the engine or doing whatever you need to do, popping out the crankshaft, it doesn't accidentally fall out and you don't see it. So find something appropriate that fits down inside there to take out that spring. More than likely, it's not just going to fall out because it's going to have some amount of grease or oil that's holding it in. So what I like to use are these Carburetor jet gauges, and they come in a lot of different sizes. This is for full scale carburetors. This is what I like to use to set up my barrel gap down inside. So if it's a 1mm gap, you get a 1mm jet gauge or something that's equivalent or close. You put it down, set your idle gap adjustment, and then you have a good reference point. instead of trying to guess and check or use something that is not actually a physical gauge like this. And you can use your dial caliper and check them just to make sure. But it's a great size. You can stick this down inside of here into the middle of the spring and pick the spring out. It's hard to do here on camera at this angle. That just helps to pick that little spring out. You set it to the side with your pin, and then you're able to go ahead and put it back in at a later time when you're reassembling. So now we're able to go ahead and take off this head. Let's pop out these head bolts. Let's give one a little measure. So these are M2.5 bolts, which do not provide a ton of stability, but it's definitely sufficient. I would love to see an M3 bolt. And these are a 12 millimeter long. When I reassembled this the first time, I like to use these small M2.5 washers. On these heads, the hole itself is kind of big. This is not something you have to do, but take a look. This is 3.3 millimeter. It's definitely oversized for these small bolts. And so a little bit more surface area using those washers is a great thing. So feel free to use that as a tip. You don't have to. The manufacturer, doesn't have them, but that's what I prefer to do with these style heads. So this is a multi-airflow directional head. That means that airflow can move in not just 1 and 2, but all 4 sides. It's completely open with tons of fins. It's an oversized cast aluminum head, help to keep these 18 size engines nice and cool. Notice the compression bowl is not integrated, and that's because these engines use a underhead or a button head. Go ahead and pop this button out. We have our head shims. See if we can't pick them off. We got one. We've got 2. They're both, oh no, I was wrong. We have 3. These are all brass. Let's go ahead and give them a measure. So we have a 0.3, so it's already relatively big. We have a 0.4 and a 0.3. So that is a 1 millimeter shim stack, which is very large, but it all just depends on how the design is done with the compression bowl, to the amount of distance between that compression bowl and the top of the piston. Also, these are ready to run engines, so that 1 millimeter shim stack can definitely be reduced. Feel free to give that a try with different nitro concentrations. See how your engine runs, especially as you go up in nitro percentage. You want to increase your shim stack, but if you're going to be running lower nitro concentrations, you can maybe take a shim out and see how that works out for you. Okay, so I had to do a little pause and take a look at the manual about these shims, because that just seemed like a lot of shim stack for this particular engine. So the part number for these shims is actually 1418, and these are supposed to be all 0.2 millimeter shims. So when we go ahead and measure this, this is definitely measuring a 0.4 shim. Now what I'm thinking though is that there is a pretty heavy burr on one side, because these parts are stamped out in the millions, and it's possible that the die that was used was a little dull, and especially on this edge here, it is rather thick. So maybe let's measure this in a little bit different area. And that shows a 0.3. And then maybe let's attempt to just get a portion of the jaw here on the dial caliper. I don't know if you can. All right, so there we go. This is a 0.2 shim. That burr is so large that when you measure across the face of these, it's measuring another 0.1 to 0.2 extra, so up to 0.4 millimeter on these shims. Now they all kind of nestle together as long as they're put in the same orientation, so there's a good chance that when you install it onto the engine, that shim stack will be appropriate at 0.2. But because these are so severe, and I didn't notice this the original time when I opened this up, I may actually take my stone, a 320 stone or a 500 stone or something, and very lightly rub these on that water stone and try to get rid of that very heavy burr to try to make sure that these do register at a 0.2. So I originally said that this is a 1 millimeter shim stack, which is ridiculous amount, but it's not. It's actually a little bit smaller, but still pretty heavy at a 0.6 shim stack when all three are put together onto that head button. So go ahead and run your engine and see how it performs. These are RTR engines, so a lot of times the pinch is not as severe and the shim stacks are a little bit bigger. For example, on the 15FE, that's Toki made, those are actually a 0.5 shim stack. So we may at a later date do some tests with some nitro concentrations or just take out a shim and see how it performs. We have a T3.0 on our carbon fiber RS402, so we might be able to play with that in the future. So let's get back to the more exciting part. Let's go ahead and take out the sleeve, get the piston out of there, and continue on with our adventure. Take a grab of that sleeve, set that to the side for a moment. When you're talking about small block engines, 0.18s are always great to go through. The pistons themselves, the sleeve, they're all much bigger compared to our 0.12s. So let's take a look at our piston here. We have a single oil groove. This is a flat top style piston. This is a non-floating, it's a captured style wrist pin. There's a clip on both sides. One end is open. This is a cast piston that's later machined, but this looks to be a billet connecting rod. The edges are a little bit beveled, but I definitely would not call that a knife edge connecting rod, but it does have a little bit of bevel to cut through the air and fuel mixture down inside of the block. This has an O-ring down on the bottom, pressed in brass bushings for the connecting rod, and it's a decent little setup, especially for this RTR style. Notice that there's a cutout on both sides of that piston skirt. So the piston itself is relatively modular, but the connecting rod itself will still have to go in a specific direction. And so this particular one, where the groove and the oil hole will face towards the front of the engine, towards that carburetor side. Let's get this crank out of there. As I said before, this is an SG style crank. There's not a whole lot that is going to be done to this ready to run style engine. That induction window definitely could be ported out a bit, but it's still has a nice sweeping ramp down inside. A nice big bore there on the balance lobe. Let's go ahead and give that a measure. It's always interesting to compare how these engines are designed. So this is a 7.2 millimeter opening for this 18 size engine, which is pretty big, I would say. The balance lobe itself has been cut out for some weight reduction, but there's nothing else that has been done to it. No fang, no shark fin, no cutout on the top side near the connecting rod journal. Just a pretty standard RTR 18 size crank. Take a look at the block now that it's pretty bare. These use chrome steel bearings front and rear. Have a black shield on the front. You could always upgrade your bearings if you so choose to, but with these being ready to run style, there's nothing real race about it, but they do pack a nice little punch in a small package. So let's go back to our sleeve here. So this is an ABC construction. We have an aluminum piston, we have a brass sleeve, and it's chrome lined there on the interior. We have our exhaust port here. It's just a simple rectangle, no dog ears, no bevel, just a big open port. It kind of reminds me of the older ABN style engines. It just does its job out that side exhaust port just to get that flow out as best as it can. Now if we take a look at our transfer ports, these are a lot nicer. It's not very tall or wide, but it has a decent width and has a nice big bevel there. No fang, but it has a nice big bevel. Helps to lead it into that compression chamber. And the same thing mirrored on the other side. Nice big bevel down below. This definitely could use some fangs, some modification to help out with some flow. There's a bevel down below. It's not extreme. That itself too could have a little bit of update, and there is a tick of a bevel on the inside as well. But then we come around and we look at this boost port. This is one of the smallest boost ports I've seen in a long time, especially on a bigger displacement engine like a .18. It does have a decent bevel down on the bottom, but this is a very small boost port. Take a look at the transfer ports, take a look at the boost port. That doesn't mean that the engine doesn't perform. It's just, for whatever reason, when they were doing the development of this engine, they either decided or found out that that size boost port is effective. It may not be the best, but it's at least effective for this displacement and power of the engine. And the engine itself is rated at 2.2 horsepower, which honestly seems a bit extreme for this style engine, but that's what they rated at. I even did a comparison between the T3.0 and the 18 CVR, the OS engine that was rated at 1.3, 1.35 or something like that horsepower. And the CVR edged that out. And we can talk a little bit more about that when we overview the T3.0. Nonetheless, this is a great little engine from Force, and it provides an engine in a sector that is very much needed in our 10th scale and some 8th scale cars and trucks. If you enjoy these style engine overviews, then feel free to take other adventures with me with some additional current and some vintage style engine overviews. Feel free to like, share, and subscribe. And if you like 10th scale, Nitro, and especially touring cars, then this is a place to be, and thanks for taking the adventure with me.